Hi everyone, thanks for checking out this video. So in this lesson, we're going to write the matrix multiplication operation for our tensor type that we're working on. And this will include both the forward and backward passes. So it kind of sounds like a lot, but just to keep saying what I've been saying, we've already done the hard part already when we were making our value data type. So this video again is going to be just a little bit of copy and pasting some things we've already done for values and just updating them to make them appropriate for tensors. The only hard part really, like I've been telling you guys, the hard part at this point is not the concepts because we've already done like the concepts already. The only thing that might make this video a bit confusing is just remembering like what matrix multiplication is. So this might take a little bit of a linear algebra review for you guys. So I'll just leave this for you guys to do on your own if you forgot what matrix multiplication means, but it doesn't mean just multiplying every element in one matrix by the corresponding element in the other matrix. That's like a element-wise multiplication. But when we're talking about matrix multiplication, we're talking about this like kind of complex arithmetic between matrices where we're doing like linear combinations of the rows and columns of the input matrices. So to get the first so to get like in this one like the first row and the first column of the resulting matrix, we have to basically take like the linear combination of the first row in the first matrix and the first column in the second matrix. So I'll leave that to you guys to do a little review on your own if you want to. But yeah, it's like I've been telling you guys, we already did like the hard part, which was the actual concept of the operation tracking and forward and backward passes. The only thing that's going to make the tensor operations harder is that the actual arithmetic is more confusing because we're dealing with matrices now. So it just makes it more confusing. But in terms of the actual concepts, it's basically going to be the same as what we've already done. Okay, so I have all the previous codes so far, so just make sure you guys have that up in one of these top cells so that we can keep using it. And then, so what I'm going to do at this point is I'm going to grab, I'm going to copy and paste our multiplication for values, and we're just going to start working from here, basically. Quick note too, you guys might remember that for values we started with addition because that was the simplest. We're going to start with multiplication for our tensors because when we do addition, we're going to add a little bit of like extra functionality that will make it like not quite so simple. So for the tensors, the multiplication will actually be the easier one, I think, to start with. Okay, so just going to grab that, copy and paste. And yeah, now we're just going to, like we've been doing, we're just going to like make some small modifications to make this work for our tensors. So first of all, the inputs A and B should be of the tensor type. This line actually we can actually keep the same because at this point A.data and B.data are both two-dimensional arrays, and so Julia will be able to do this matrix multiplication automatically, basically. So this is just like a built-in function of Julia. Is if you do matrix multiplication with two arrays, then it'll just do it automatically with the multiplication operator. Okay, so for the result, couple things to change. First of all, the result should be a tensor, and then yeah, so we need tensor, we need the tensor.data, tensor.grad, and tensor.op. Okay, so yeah, the data is going to be the same. This will just be out. We just calculated here. Remember, this out is a matrix at this point because we just multiplied two matrices, and Julia just did the matrix multiplication for us. The operation is still the same because it's still multiplication, and then we're storing the operands A and B that went into this operation. The only thing we need to change here is we need to make this grad, rather than just 0.0, we need to make it an array, two-dimensional array full of zeros that will be the same size, same shape as our alt matrix. And remember, the out matrix could be a different shape than the input matrices, because just remember, yeah, the way it works out sometimes is you get, again, the confusing thing about just the arithmetic here. Yeah, you can get the output matrix having a different dimensions, different shape than the input matrices. So yeah, just going to actually copy and paste a little bit here. So yeah, this part here is just saying, okay, we're making a two-dimensional array full of zeros, type float64 for the elements, and it's going to have the same size as this output array. Yeah, and I'm just going to remove this comment because it's not a value anymore. But yeah, at this point, I think we should be good. Yep. And then you guys can test this out on your own if you want to. For these tensor operations, I'm not going to be doing as many of the like actually writing tests. Just because it'll be a little bit more complicated and a little bit more time consuming. So I'll leave that to you guys on your own to test this out to make sure it works. Yeah, again, this was the point of the value type. Was the value type allowed me to like teach the concepts to you guys, the forward and backward passes and the operation tracking, to teach those concepts in a way that we could easily check our work and make sure that it was getting it right, just by like kind of doing simple examples and looking at it. So now that we're doing the tensors, I'm going to ask you guys either to test it on your own or to just take my word for it, basically. Yeah, because the testing at this point will be a little bit too time consuming for these videos. So I'm going to ask you guys either to just take my word for it or to just test it on your own to make sure that it works properly. Okay, so now we need the back prop. So again, I'm gonna copy and paste one that we've already done. Okay, copy and paste this back prop for value multiplication. So if you guys remember, this back prop is saying, okay, this is what we're going to do to update the gradients. If we pass in a tensor and we're calling this back prop function on a tensor, then we want to update the gradients of the operands that went into the operation to make that tensor, basically. So if we have some tensor that was the result of this A times B matrix multiplication, so we're basically calling back prop on this tensor, and then we want to update A.grad and B.grad. And again, we can do it pretty similar to how we already did it, just making a couple small changes here. So we're going to say, okay, this is going to be, rather than val, we're just going to say tensor. It's going to be type tensor, where this tensor has some like operation type here. And I'm going to say, okay, where fun type is type of multiplication, and then arg types. So that part we can actually keep the same. Again, this whole concept of what we're doing here is called multiple dispatch. Basically, we can instruct Julia functions to do different things. Even using the same function name, we can have this backprop function name do different things based on the type information we have about the input. So we already defined what this will do when it has a value that was the result of a multiplication of values. Now this is instructing it to do something different when it has an input that's a tensor that was the result of a multiplication of tensors, basically. And okay, now we need to do something a little bit complicated. I'm actually just going to copy and paste a little bit here, so sorry for being lazy. And yeah, so this is what the backprop actual like function is going to look like for tensor multiplication. Again, so this is probably going to look to you guys not very intuitive, and to be honest, it's not very intuitive to me either. But this is just the way that the gradient updating is done when you are updating the gradients for the operands of a multiplication operation. So yeah, again, this is why we did the values first, was because for the values, the gradient updating was like somewhat intuitive. Now that we're doing it for tensors, I'm going to ask you guys to just take my word for it, because I realize it's not very intuitive, but it's similar to what we were doing for values for the gradient update for value multiplication, except that again, it's like with tensors, now that we're dealing with two-dimensional arrays, the actual arithmetic is more complicated. But besides the arithmetic being more complicated, I mean, yeah, we have like a transpose here, and stuff like that, and these are all like everything in this is like a matrix, by the way, so or like a column vector or a row vector. So all of these are like array operations rather than just number operations. But the thing that's similar to the values is that this line here, tensor.op.args1, that is another way of writing A, basically, because this is how we can get back to this pointer to the operand, or sorry, both of the operands that went into making tensor is with tensor.op.args. That gives us a tuple with the operands, and in this case, like if we're calling the operands A and B, then taking the first of those operands will be A, and then so this basically is just another way of writing like A here, and then .grad allows us to update the gradient of this operand A, basically. But yeah, and then it's like I keep saying, like the arithmetic is more complicated, but basically like the concept of what we're doing is similar to what we did for the values. And then same thing with the second operand here, again calling .grad to update the gradient, incrementing it just in case the same tensor was used like more than once to reach the final output. And then this times tensor.grad is our way of like chain ruling back, basically. But yeah, the arithmetic is actually pretty complicated, and with this, again, I'm not going to write a test right now. I'm going to leave it to you guys to either test this on your own, or we're going to basically do, for the tensors, at the end, after we set everything up, I think the last video is going to be a final test, where we do like a test test by effectiveness, basically, showing that we can use our tensor class to actually solve like a real neural network deep learning problem. But yeah, for now, I'm not going to write any tests for this. This will just be left up to you guys, or you can just take my word for it. But yeah, hopefully you guys are seeing like why we spent so much time on the values. The point of the values, like I keep saying, was to just build up intuition for what everything is doing here, because now that we're dealing with tensors, it's harder to see intuitively what's going on, basically. But yeah, hopefully we remember from the values, like kind of the basics of it. Okay, one last thing for this video. So just like with the values, like each operation has a backprop function to do like the backward pass for that specific operation. But we're also going to have this like full backward pass that we just call this backward pass on to go through after we have some final output, some final resulting tensor. We'll call this backward function on that final output, and that will calculate the derivative of the final output with respect to all of the inputs that went into it. So we did that for values already, and now we're just going to do the same thing again for tensors. And again, we're just going to copy and paste and make a couple like small changes. Yeah, okay, so what do we need to change for now? Okay, so backward's going to be it's going to be taking some input A, which is going to be type tensor. So A here is like the final output of some series of operations. And then this will calculate the derivative of A with respect to everything that went into it. All the elements of all the different matrices that went into it. We'll be calculating the derivative of A with respect to all of those, basically. And again, we have our build topo function. This is going to be, again, basically doing the same thing, except everything is going to be of the tensor type. I'm not going to explain this again. If this looks confusing to you guys, please go back and watch the video where we explain this for values. Yeah, because now it's basically the same concept, but just doing everything again for our tensor type. But yeah, if any of this is confusing to you guys, rather than explain it all again, I'm just going to invite you guys to like check out the video several videos ago where we did this for the values. But yeah, same thing. Now just going through, checking to make sure everything is the right type. Should all be tensors now rather than values. Okay, just seeing what I need to change here. Do I need to change anything? Okay, and we call our build topo. Okay, so something here. For the values, we set a.grad equal to 1, but now that a is a tensor, we need to set every element of a equal to 1. So this dot is setting every element of a.grad. So this if you do dot, if you do dot and then some operator for like an array operation, it basically does it for every element. It's like an element wise operation basically. So this will set every element of a.grad equal to 1. And then yeah, I think that's it. Yeah, other than that, it's basically the same as before. So again, if you guys don't understand anything going on here, please just check out the previous video on it. But yeah, other than that, it's basically the same as before. Yeah. So sorry guys, for this video, we're not going to do any actual tests of this stuff so far. That was kind of the point of all the value videos we did, was to test out all these concepts and make sure they make sense to us intuitively. Now that we're getting to tensors, I'm just going to go through and like continue writing all of the operations we need until we get to the end, and then we're going to put it all together to actually write a neural network and train it for like a real deep learning problem, basically. So that will be the final test, is when we actually test out this tensor code on the real machine learning problem. But for now, I'm not going to be doing any tests. I'm just going to leave it up to you guys to either test it yourself or to just go back and watch the value videos to just make sure you have like a solid intuitive understanding of what's going on with all these parts here. Okay guys, thanks for watching. Just as a reminder, all this code is all up on my GitHub. Yeah, it's all up on my GitHub. The link will be in the description. And then just as a reminder too, this whole thing we're doing is based on this SimpleGrad library. So this is the SimpleGrad library. This is like the documentation site. It's also the GitHub page here. Yeah, so if you guys want to check it out, I'm basically showing you guys in this video series how to build this real like SimpleGrad like package that I made step by step. So yeah, it could be cool to check out if you want to. Okay, thanks for watching, and see you guys next time.